Alright, so this is sort of an odd exercise because, I don't know, maybe I'm just doing it wrong, but this seems very disjointed and none of the parts are really related in any way. Um, so show that d2 of f equals g2 of xy for f written as above. So if we do, let's see here, d2 of f of x, y, this is, okay, so first we take the derivative of the first thing, or the first term. The first term here is the integral from 0 to x of g1 of t0 dx. Well, this does not depend on y at all. And so that is just going to be 0. Okay, so that first term is 0. And then for the second term, we take the derivative. So here, I'll just write, so I won't even, here, sure, I'll write the first term out. g1 of t0 dt plus d2 of integral from 0 to y, g2 xt dt. So the first term I've written here is 0. The second term, we're taking the derivative with respect to y of an integral from 0 to y. And so by the fundamental theorem of calculus, this is just g2 of x, and you evaluate it at the variable with respect to which you're taking the derivative, and so that's going to be y here. So that uses the fundamental theorem of calculus, which we haven't learned because we haven't learned how to integrate, because we haven't gone there yet. But I guess we're supposed to sort of know it already. There's a lot of these exercises where, like, it really does make sense if you sort of assume the background calculus knowledge. These are sort of nicer exercises. It's cool to be able to do some of this stuff. But since we haven't technically learned it, this is technically not rigorously done, because you have to prove the fundamental theorem of calculus before you can use it. But anyways, this is something that I complain about a lot with this textbook, so I won't waste any more time on it. Okay, so how should f be defined so that d1 of f is g1? Well, basically, we just flip all the x's and y's and the 1's and 2's. So if we set f of x, y to be the integral from 0 to y of g2 of 0 t dt plus the integral from 0 to x of g1 of x no of t y dt. And then if you take the derivative of this with respect to x, again, the first term here does not depend on x at all, so it will be 0. And the second term, you use the fundamental theorem of calculus, and you'll get g1 of x comma y. And the weird thing is, how should f be defined so that this derivative holds? This is sort of I don't know what question he's trying to ask, but I feel like it's not this one, because this question has multiple answers. See this integral from 0 to y of g2 of 0 comma t dt? We could replace that with any function which does not depend on x. Literally any function which does not depend on x. And this would still be, f would still satisfy d1 of f equals g1. So I don't know why they wanted us to see this. I guess what they just wanted us to see is that if you move around the x's and the y's, then you can get a very similar result. And then C is weird because I don't understand how we're supposed to use parts A and B here. I guess it's helpful to get you started. Because let's see here, if f of x, y equals, okay, so we want d1. So let's just start with the part A. So d2 of f equals this thing. So we want g2, so when we take d2, we want to get y. So we want g2 of x comma y to be y. So we're going to have the something plus the integral from 0 to y of t dt. And then, let's see, if we want to get if we want the derivative with respect to x, with respect to x to be x, then we need to do the same thing for the first term, t dt. So then, of course, as I've said, d1 of f x y will be x, because you'll get first term will be x by fundamental theorem of calculus, second term will be 0, and d2 of f of x y equals y. So then for the second one, so if you want to set f of x y to be, well, you could start by doing, like, maybe try to set g1 of x comma y to be x, so that you'd have the integral from 0 to x. Well, wait, I guess this doesn't even really make too much sense. Basically, so here's what it is. It's just x times y. And I'm not exactly entirely sure how the first part is supposed to be super useful in obtaining this. Well, wait. No, it would just be the integral from 0 to y of x, which when you evaluate it, because there x is just a constant function, so it's just x times y. And then you've already got a function which works. And so you don't even need anything for g1. So anyways, so then obviously d1 of f x y, take the derivative with respect to x, then y is a constant, and you take the derivative of x, you get 1, so this is just y, and d2 of f x y equals x. Okay, so either there is something a little deeper and some ideas that are connecting all three of these parts that he's sort of trying to guide you towards, and which I just am not seeing here. Or this is just sort of an oddly worded question. I think, like, if there was some way to, like, combine or to use all three of these parts in a way that relates them all, then it could have been phrased in a way that leads you to that better. Or maybe it is phrased in a way that leads you to that, and I'm just not seeing it for whatever reason. But in any case, this is all that you need to do for this exercise, and so we are done.